So yesterday we were discussing this question, right? So we have 10 volt, we have R, we have R1 value is R, R2 value is also R, R3 value is 1.1 R, and R4 value is this. This is given. So how can we find this particular questions? You need to find the value of VAB. Okay. So how can we find this question? How can we find this particular question? So, so guys, we were doing the questions, this question. So you need to find the value of V, A, B. So have you solved this question? Means anyone? Prasanna, have you tried this question by yourself? Yesterday, because the network, because of that network issue, I have to leave that question. So you have tried this question, guys. Anyone tried this question? Question number 25. Okay. So see, how can we solve this question? You need to apply the KVL KCL only in this particular question. We have, that is R. The value of this is R. This particular is also R. This is your R only. This particular value is 1.1 R, and here it is given, it is grounded. Okay, and potential across this positive, negative, this is also grounded, and this is your positive, negative. Yes, if you are assuming this as a A and this as a B, you need to find the value of VAB, and this particular value is 10 volt. It's given that it's a 10 volt. Okay, so this particular is 0 because it is grounded 0, that's why I'm taking 0. Okay, this particular thing is 0, and if it is 0, if this thing is 0, means your voltage across this is, if you are assuming Vx, so Vx minus 0 is given, Vx minus 0, it's given as 10 volt. So what is the Vx value? Vx value is 10 volt. Okay, so if you are assuming the Vx value is 10 volt, now suppose I am assuming this is my I current, this I current, this particular is I current. I am getting here I1 current, and here I am getting I2 current. One is I1 current and one particular is your I2 current. And from here you are getting your I current. Okay, this I current is going like this. Okay, now, and suppose this is your VA point and this particular is your VB point. Okay, now if you will apply the KVL, if you will apply the KVL, what you will get? Minus 10 plus I1 R, here I am assuming some particular I2 current. This is your I2, so I have to assume I3 current, and here I3 current. So minus 10 plus I1R plus I3 R is equals to 0. So you are getting some equation I1 plus I3 into R is equals to 10. Right? Just wait. Someone is coming. So you are getting particular equations, what? I1 plus I3 into R is equals to 10. This is one equation. Because this Wheatstone bridge is not balanced, and if you'll apply the same KVL around this same KVL, you will get something like this: minus 10 plus I2R. Let me make, someone is coming. Actually, I am making you a host. Please accept those persons who are coming. Okay. So this is the equation 1, means you are getting minus I1 plus I3 into R is equals to 10, and this particular is minus 10 plus, if you'll use the KVL, minus 10 plus I2R plus I3R, you will get another equation, minus 10 plus I2R plus I3 into 1.1 R is equals to 0. So what you will get, I2 plus 1.1 I3, R will be common, you are getting another equations like this, right? Another particular equations you are getting I2 plus 1.1 into I3 into R is equals to 10, and one value you are getting I1 plus I3. Okay, let assume this particular Ix value. If you'll apply the KCL here, what will be the KCL in this particular A junction? What is the incoming current? I1. And what is the outgoing current? Ix. What is the outgoing current? Ix plus I3. So what will the value of Ix? Ix will be I1 minus I3. Okay, this particular is the Ix value. And if you will use these particular equations also, Ix in this particular junction, so what the equation you will get? I2 is your incoming current and Ix is your incoming current, which will be equal to I3. So Ix value is also I3 minus I2. So what you are getting, one particular equations, what you are getting, this is I1, this is I2. Yeah. So if you means first what we did, we had just assumed that Vx value is 10, and we got the value of a Vx is equals to 10. We had applied the KVL here in this part, I1 R, and this particular is I3. Okay, this is your I4. This particular is your I4. Let's see, we have to assume the different current. So now if you'll apply the KVL in this particular loop, you will get minus 10 I2 R plus I4 into 1.1 into, so you are getting I2 plus 1.4 into I4 into R is equals to 10, and one particular equation is this. Now I1 is equals to Ix plus I3, and another equations you are getting I2, this will be I4, so I4 minus I2. So you are getting one relation. What is that relation? I4 minus I2 is equals to I1 minus I3, if you equate this. Okay, so what you are getting means you got one particular relations, I4 minus I2 is equals to I1 minus I3. Okay, and I3 plus I4 value is I3 plus I4 value is I. I3 plus I4 value is I, and I is also equals to I1 plus I2. So from here also you got that same relations will come if you'll use that. I1 plus I2 is equals to I3 plus I4. This is the same relations only. And one relations what you got? One relations you got as I2 plus I4, I2 plus 1.1 I4 into R is equals to 10, and one is I1 plus I3 into R is equals to 10. Now you have to use this particular equations and you will get the result. Okay, if you will use these particular equations, suppose I am taking this particular equation, this is my equation 2, and I am just equating this equation. So what will get? I1 plus I3 is equals to I2 plus 1.1 I4, right? So we are getting something like that: I1 minus I2, I1 minus I2, I1 minus I2 plus I3. This is your I1, this particular is your, if you'll come then minus 1.1 I4 is equals to 0. Okay, and one particular equation is I1 plus I2 minus I3 minus I4 is equals to 0, right guys? So if you solve this, what you will get? This will cancel out, and you are getting 2I1 minus 2.2 I4 is equals to 0. So what is the relation between I1 and I4? I1 is equals to I4, it will be divided by 2.2, means if you solve this, what the relations you will get? What particular relations you will get? If you solve this, what particular relations you will get? 2.2 I4 divided by 2.
1.1.
2.2 divided by 2, what you will get? See, this is 2, this particular is minus 1.1, so minus 1.1 plus minus 1.1, you will get minus, this will be minus 2.1, okay, minus 2.1. So 2.1 divided by 2 into I4, right? (1.05). You are getting I1 value is 1.05 of your I4 value. Okay, now you got the relations between I4, I1. If you will substitute this, then you will get the relation between I2 and I3 also. And I think you have a one relations between I2 and I3. Okay, can anyone tell me, you got the value of I3 is there and I4 value is there. Okay, now what I am telling, you know the value of I1 and I4. I1 value is this particular I1 value, this particular is your I1 value, and this particular is your I4 value. Correct, this is your I1 value and this is your I4 value, and you know the relations between I1 and I4. Okay, if you can apply like this, minus 10 plus I1 into R plus VAB plus 1.1 into R into I4 is equals to 0. You will get the value of a VAB. 10 minus I1R and minus 1.1 R into I4. Okay, you get the equations of this VAB. Okay, 10 I1R minus 1.1 R into I4. So you get one equations from this particular equations, and just try to get the equations from this loop also, and this branch loop also. Okay, you will get another equation in terms of a VAB. Okay, and you will get another equations if you apply the KVL in this particular loop also. And what you need to do, you just need to solve the equations. Okay, so this seems to be very difficult, means if you will do like this and this, so that's why this seems to be very difficult if you'll go like this. Okay, that's why we have to study a particular theorem that is known as a Thevenin's theorem. Okay, Thevenin's theorem is there. There is another theorem, that is a Norton's theorem. So I will discuss these questions, means how simply we can solve if we know the Thevenin's theorem, Norton theorem. In a very few seconds you can able to solve these questions. You don't have to go through this equations like what we are doing here. Okay, so write down the next topic. We'll start and we'll see these questions after studying this particular topic. So theorems. So we are going to start the new topics, that is theorem. Okay, so what do you understand by theorem? So have you studied in your BTech, guys? Theorems have you studied? Prasanna, have you studied theorems in your BTech?
Yeah.
So in first semester or second semester or third? Okay, so we are going to start the chapter 4, that is theorem. Okay, suppose you have a particular equations y of t is equals to 2x of t. Okay, so you are assuming this y of t is your v, and this x of t is your I, and this particular 2 is your r. It's just an example, and you can also think like this: I is equals to j into v. Okay, or x of t can be written as 1 by 2 y of t. Okay, so suppose if you multiplied a with x of t, if you will multiply a with x of t, then what will be the what the things you will get? If you are multiplying a particular a, so your y of t is becoming how much? 2ax of t. 2a 2ax of t. Okay, means I'm just teaching you the linearity for superposition theorem. 2ax of t and a2x of t, this is your y2 of t, assume. So it's getting multiplied with a y of t only. So a is multiplying with your y of t only. Okay, means if what I want to say you, if you are scaling, if you are multiplying any scalar number to input, this y of t is equals to 2x of t. Okay, so this is your output. Okay, and this particular x of t is your input. Okay, so if you are changing your input, if you are changing, means your input, first input was x of t. Now if you are changing your input by multiplying with ax of t, if your output is also getting multiplied with that particular scaling, that particular number, then it is a linear. So so now I have changed our input with ax of t, and if you will take the common this a, if you will take the common, this particular a, if you will take the common, what you will get? This a is taken as a common. What you are getting? 2x of t. This is what? This is your earlier y of t. Say y of t. So our output is also getting scaled by a y of t. Okay, this is one property. Means for we are discussing the superposition theorem. So for superposition theorem, linearity and homogeneity both should be means if linearity and homogeneity is applicable only, then you can apply your superposition theorem. Okay, so linearity, how to check the linearity? By this way we are checking. Okay, now if anyone is asking about homogeneity. So suppose you have x1 of t, y1 of t. So y1 of t is equals to 2x1 of t. And now if you have x2 of t, your y2 of t will be 2x2 of t. Now if you added this particular term, x1 of t plus x2 of t, your new x3 of t is becoming like this. Okay, so your y1 of t plus y2 of t, we are getting 2 x1 of t plus 2 x2 of t. This 2 is common, already we took. So x1 of t plus x2 of t. So this is what, and I just told you this is your x3 of t, and this is your y of t. So you are getting the same thing, means the same. This is your function. This was your input. So if you adding the two different input and you are getting the same like a same function like your output, that means your system is additive. Means it is homogeneous principle is applicable. Okay, so let us suppose what I'm saying. Now suppose your y of t is equal to x square of t. Okay, now if I'll say you have to take x of t, new x of t is equals to ax of t. If you'll apply this, y of t, what it will come? A square x of t. Okay, you had applied a, but you are getting, means you had scaled your input by a, but your output is scaling by how much? A square. Okay, so we need to get the result like this: y of t is equals to ax of t, but what we are getting? A square term. So here the system is not linear. It is not linear, because we are not getting the terms a, because if we scaling the term with a, our output is also scaled by a, then only our system will be linear. But how much we are getting? Here we are getting a square. We have to get the value ax of t, but we are getting a square terms. That means the system is not linear. Guys, it is clear? And suppose for homogeneity, if you are having x1 of t and new terms you are taking a x1 of t, okay, or means we are just taking the homogeneity. So just take your x1 of t. So y of t, y1 of t belongs to x1 square of t. Okay, and x2 of t, y2 of t belongs to x2 square of t. If you will add this result, y1 of t plus y2 of t, what you are getting? x1 square of t plus x2 square of t. You are getting like this. But what is the function? You are having y of x, and you have to get the result like this, x square of t. But we are getting the additions like this. We need to get the additions, means like our input should be x1 of t plus, if you are taking your, now suppose if you are taking your new input x3 of t, what I am telling, if you are taking your new input x3 of t is equals to x1 of t plus x2 of t, x3 of t, you are putting x1 of t plus x2 of t. If you are substituting this in your real equations, what you will get? Y of t is equals to x1 of t plus x2 of t the whole square. But if you are doing separately and adding, you are getting the result like this. So this is not equal to this. So this is not following the homogeneous principle. Is this point is clear for everyone? Prasanna, is this clear? Prasanna?
Yeah.
Okay. Write the statement. In linear bilateral network, containing more than one independent source, independent source, okay, independent source, the response in any element is the sum of the response obtained with one source, obtained with one source acting at a time, and other sources are deactivated. But you have to remember this point. Your linearity and homogeneity principles should be applicable. So what is the meaning of a deactivated? Deactivate means all the independent sources are replaced by internal resistance. Meaning of deactivate means all the independent sources are replaced by the internal resistance. Okay, that is voltage source by short circuit, and your current source by open circuit. Okay, voltage source will be replaced by short circuit and current source will be replaced by open circuit. Okay, while all the dependent source remain there. While all the dependent source will be there only. Source will remain there. So this is very important point. Dependent source, we don't have to do anything with dependent source. Okay. Now this is a very important point. Note it down. Superposition is not valid for network containing non-linear element. Okay. Superposition theorem it is not valid for network containing non-linear element. Non-linear element means like diodes. Okay, non-linear elements. It's like diode. Non-linear, how you will check the non-linearity? Like that what I did in the previous slides. Okay. Non-linear elements. And for non-linear parameters such as power. And for non-linear parameter such as power. How so? See, what is the equation of a power?
VI.
You have to say in terms of a resistance. Okay, you have to take only one things as a means two things as a variable. Power is equals to, you said V into I, and what is the equation of either you consider V as your another equation, or consider I as your another
I
equation, I square R. Okay, so this is one equation. So how you will check it is linearity or non-linearity? So suppose you are taking you have a input, means input is what? Here input is I, okay, and output is power. And what is the factor? Means R will always multiply it. Suppose you having means I'm considering for linearity. If you want to check for a linearity, now you had scaled your input by alpha I1. So apply this in this. Now your input is this is your input. If you'll apply this in your input, what you will get? P1 is equals to alpha I1 the whole square into R. So what you are getting? P1 is equals to alpha square into I1 square into R. But I told you, if you are scaling your input and if your power is coming like this, alpha I1 square into R, that means it's okay. It's P1 into alpha, that is okay. That is means if I am scaling our input by alpha, our power is scaled by alpha, then it's fine. This is linear. But see here, the scaling factor is coming how much? Alpha square. That means this is not linear. So in power we cannot apply superposition theorem because linearity is not there. Got it? Everyone got this point or not? As this point is clear for everyone? Okay, fine. So yeah, now you need to do one calculation, guys. You need to do one calculation. Suppose you having one network. Your network is like this. This is your 4 ohm. This particular is your 4 ohm. This is your 3 ohm. This positive negative is 12 volt. It's 12. Okay. And this is your 3 ampere. Okay. And this is your 8 ohm. Okay. Find the value of a current I. You need to find the value of your current I using superposition theorem. Okay. Now can means how many dependent sources are independent sources are there? How many independent sources are there? This is your one independent source. This particular is your another independent source. So for superposition theorem, what you need to do, you have to deactivate your one independent source. So I am deactivating this current. So if you will deactivate this particular current, what the new circuit you will get? 4, 3, this is 4. If you are deactivating current source, it will become open circuit like this. It is open. Means infinite amount of resistance is there. No current will flow in this. This is your 8 ohm. And this particular is your plus minus 12 volt. You need to find the value of I1. Guys, how you will do it? So see, if this is open, now what is the relation between this 8 ohm and 4 ohm? This 8 and 4 are in series or parallel? Same current will flow in this because this is open. So 8 and 4 are series. So you will get 12 ohm. This particular is your 4 ohm. This is 3 ohm. This is your plus minus 12. This is parallel connection. So what you will get? 12 into 4 divided by 16. 3. You got 3. You got 3 here. This is your plus minus 12. So what will the net amount of current flow in this? 12 by 6. I1 value, that is 2 ampere. You got the value of I1. Now what you do? Now in the second, if you are going for the second second source, you need to deactivate this and activate this. If you will do this, this is your 4, this is 3, this particular is 4, this is your 8 only, and it's activated, so it will remain like this, and 3 ampere. Deactivated of voltage source means what? It will short circuit. So it gets short circuit like this. This is 3. Now, so you need to find the current in this particular current you need to find. So guys, how you will do it? How you will do it? If you need to find this particular current, these are short circuited. This particular are short circuited. Okay. So if you want to find the value of a current in this, how you will do it? Means see, this, if you are taking this as a point, this as a B point, this is also B point. So we are clearly seeing that these 4 and 3 are in parallel, right? 4 and 3 are in parallel. So these 4 and 3 network are in parallel. Okay, by the way, if you solve this network also, it is a parallel connection. These 4 and 3 are coming as a parallel connections, and you can make like this circuit also. This is your 4, this is 3, it's parallelly connected, and here it is your 4. Okay, and you need to find the value of this you are assuming A, this is your B, and this particular current source is 3 ampere, and this is your 8 ampere. You need to find the value of this current from A to B, and here overall current is flowing how much? Overall current is flowing how much? It's flowing 3 ampere only, right? 3 ampere current will flow in this. Okay guys, if you will solve this particular network, so what will be the overall current in this? 4 into 3 divided by 7 means the overall resistance in this 4 into 3 divided by 7. So you are getting 12 by 7. This branch resistance is becoming 12 by 7. And this is your 4, and this is your 8, and you have a current like this. Okay, now suppose if you are solving this particular network, 12 by 7 plus 4, 12 by 7 plus 4, 28 plus 12 by 7, how much it will come? 40 by 7. So you have a network like this, 40 by 7. This is your 8. This particular current is flowing. This is your 3 ampere current. Now you need to find the value of a current in this. Suppose I want to find the value of a current in this way. This is getting splitted into two parts. This is your I1 part, this is your I2 part. Okay, so apply the current division rule. So for current division rule, if you need to find the I1 value, you have overall current is 3 ampere. You need to multiply it with 8 divided by 8 plus 40 by 7. So you are getting the value of I1. What is the I1 value? 24. Solve it and tell me the result. 8 is 24, 24, 7 will go upside. So 8, 7 is 56, 56 plus 4, 96. So how much you will get? 24 into 7 divided by 96. This is your 96. So you are getting means I1 current is 7 by 4. Okay, but you need to find the current in this branch A and B. Okay, so you know in this particular you understood because you got the current that is nothing but that is 7 by 4. 7 by 4. Now 7 by 4 current is again splitting into two parts. Suppose I dash and suppose it is I double dash. So you need to find the value of I double dash. What you will get? Do 7 by 4 into multiplied with 4 divided by 4 plus 3 7. 4 plus 3 7. So this 7 will get cancelled out. This 4 this will get cancelled out. You are getting I1 double dash, that is 1 ampere. So 1 ampere current will flow. So what will be the overall current? You got the I1 value is 2 ampere. Here you got the current in this, that is 3 is your 1 ampere. So overall current I1, that is 2 plus 1, that is 3 ampere current. 3 ampere current will flow. Guys, this part is clear. Always remember, means current division rules I teach you. If this particular is R1, this particular is R2. If you want to find the current in this, I1 will be overall current multiplied with opposite branch resistance divided by overall resistance, R1 plus R2. So I use the same concept. I just decoded this circuit like this. We have to find the overall current in this 3 ohm branch. Okay, 3 ohm resistance branch. So by deactivating the 3 ampere resistance, we got the I current first as a 2 ampere. Now by deactivating the 12 volt potential, we got the circuit like this. We solve like this, means this 3 and 4 are parallelly connected. So I just get the result like this, 12 by 7 4, because this is the series connection, means overall current will flow. Whatever the current that's 12 by 7 is what? 7 for 20, 28 plus 12, that is 40 by 7. And now we know the current in this 3. So I just use the current division rule by using this formula, and I got the current in this branch. I know the current in this particular in this branch. Okay, means this particular current, some current is coming like a 7 by 4. Okay, 7 by 4 current is here. Then this 7 by 4 current will be divided into this particular 2 branch. Okay, so 7 by 4 I am here. I want to find in this, so I have to multiply it with 4. I have to add this particular resistance. So 7 will come. So you will get 1 ampere current. Now you know the value of 1 ampere current is flowing in this. Just add it 1 ampere with your previous current branch value. You got the result. Okay, Prasanna, is this clear? Prasanna, is this clear? Vaishnavi, is this clear? Guna, for you?
Yes, sir. Yeah.
Okay. Revise the previous topic, then you will get to know these things very perfectly. Okay, now okay guys, or guys means it's your wish, means like you can solve the network like this also. This was 4, this was 4, this particular was 8, this particular was, it was 3, this was 3, and and this was 3 ampere. Okay, and you can use the nodal analysis also. Take it V1 here, make this as a ground, make it V2 here, apply the nodal analysis, assume I1, assume I2, assume I3, and this particular assume I4. So in this junction, if you solve in this particular junction, so this is your ground, that means this is your also ground, this is also ground. So what is the outgoing currents? I2 plus I1 plus I3. I2 value is V1 minus 0 divided by 4. I1 value is V1 by 3. I3 value is V1 minus V2 by 4. Okay, is equals to 0. You know you have to solve this relation. So one equations from here. You can now analyze and use this equation. So I3 current is coming, 3 ampere current is coming, and what is the outgoing current? I4 current. So I3 is how much? I3 is V1 minus V2 by 4 plus 3 is equals to I4 is how much? V2 by 8. Now use this equation 2. You have equation 1, equation 2. You have two unknown values, V1, V2 value. Get the value of a V1. Get the value of a V1. V1 minus 0 divided by 3 do. You will get the result as a 1 ampere only. By this way you can also solve. It's up to you how you are using the theorems and all. Okay. So now in the below figure, suppose you have a network like this. Suppose you have a network, particular network like this, and capacitor value is there. Okay, so this value it's given as J ohm. This is your 1 ohm. This particular is mentioned as a Vx value, Vx dash, and capacitor value is given as a minus J5 ohm, and your inductor value is given as a J4 ohm, and here the angle is given as a 1 at an angle 0 degree volt, and here current is given this 1 at an angle 0 degree. Okay, now you need to find the value of a Vx. Okay, so how you can do this question? Same thing, apply the superposition theorem. So I will deactivate this particular. If I deactivate this particular, so my circuit will be like this: 1 at an angle 0. This will be your 1 ohm. This is your J ohm. This is your minus J5. This is your J4. this is short circuited. Short circuited means this will become redundant because it is parallel to this, so current will directly jump from here, it won't affect. So this is 1 ohm, this is j ohm, circuit is becoming like this, and this is your 1 at an angle 0. So you need to find the value of this plus minus. I'm assuming Vx here. Okay, so apply the nodal analysis and get the answer. So I'm taking here as a I1 current, this particular is a I2 current, and this particular is a I3 current. So I1 plus I2 plus I3. So what is the value of I1? It's given 1 at an angle 0 degree. What is the value of I2? It will be Vx by 1. What is the value of I3? Vx by j. So is equals to 0. Is equals to 0. What is the value of a Vx you are getting? Take the Vx common, 1 minus j. This j will go upside that it will become minus, and this will be minus 1. So what is the value of a Vx you are getting? Minus 1 divided by 1 minus j. Solve this, or let it be like this, minus 1 divided by 1 minus j. So we got one equation value. Now if you deactivate this particular thing, if you will deactivate this particular thing, now you have these things. Okay, so your circuit will become like this. For deactivating the current element, it will become open circuit. Okay, so these things will become open circuit, the remaining thing will be there. This is 1 ohm, this j ohm, this is your minus j5, this is your j4, and now you have this particular 1 at an angle 0. Now guys, see, it's very simple. You can ignore this part instead of this, because why I'm saying because this is parallel to this, so you can write simply like this: 1 at an angle 0, this is j ohm, this is your 1 ohm. You can simply, because it's parallel, no resistance is here, so that's why we can make this like this. Now find the value of, and you need to find the value of, means a current in this particular voltage you need to find. So find the value of a current. How much you will get? 1 divided by, in this way you are finding the current. So 1 divided by 1 plus j. This is your current is coming. And if you want to find the value of a Vx and this, so this I will be multiplied with your 1 ohm. So you will get the value of a Vx is 1 divided by 1 plus j. Now you have Vx2 I am taking, that is your Vx1. So overall Vx will become Vx1 plus Vx2. Now put the value 1 divided by 1 plus j and minus 1 divided by 1 minus j. Get the result: 1 minus j minus 1 minus j divided by 1 plus j into 1 minus j. It will give you 1 plus 1. This getting cancel out. You are getting minus 2j divided by 2. So what the Vx value you are getting? Vx value is minus j. That means 1 at an angle minus 90 degree volt. If this part is clear, how we did it, is this clear to you guys? See, what I did, I just first I assume this particular this particular I assume this particular voltage. So that's I have to deactivate this. If I am deactivating this, that means it's getting open circuit, or first means first I use this one. So if I am using this one, this becoming short circuit. So short circuit means, so current will directly flow like this. So this is also getting shorted. Okay, this is also getting shorted, so we have to ignore this part. Now you have the things like this, and you need to find the value of Vx across this, apply the nodal analysis, okay, and get the results. So while applying the nodal analysis, I got the Vx1 value is -1 divided by 1 minus j. How so? Current is going 1 at an angle 0, Vx by 1 is coming, and Vx by j is coming. So I'll solving like this. So -1 divided by 1 minus j, I'm getting equation 1. Now we got the Vx value. Now what I did, I just deactivated this part. Okay, if I'll deactivate this part, it will become open circuit. So you will get the equations like this. Okay, deactivated means this is opened, so this particular is deactivated. Or you can, because see, the thing is, just guys, I just want to tell you, suppose you have a 3 ohm, you have a 2 ohm, you have a some 3 ohm, and here it is given as a battery of positive negative 5 volt. So what is the meaning of a 2? This is VA, and this is VA, and this is you are taking as a 0. So VA minus 0, it's 5. Okay, so VA value is 5. So this is 5. Means across 2 ohm also 5 volt is there. So that's why I just ignoring this branch, and I can replace like this. One voltage source. We'll get the same result only. Okay, if you want to find the current in this, you can find like this also, 5 divided by 6, you will get the current. Okay, but you need to find the current in this, then you don't have to use, because you are having a 5 divided by 6 current in this, 5 by 2 current in this, then you have to add it, and you will get the 5 by 6 plus 5 by 2 current, overall current. Okay, but here our aim was to find the value of a voltage across this. So we need to find the current in this, and we just have to multiply this. So that's why here the voltage across this, that means we can ignore this simply, and we can find the current like this, 1 at an angle 0 divided by 1 plus j. Okay, you got the current. Now apply the V is equals to IR, because we need to find the current in this particular branch, 1 ohm resistance, 1 ohm Vx we need to find. So I just multiplied with that resistance. We got the Vx2 value is 1 divided by 1 plus j. Add both the result, -1 divided by 1 minus j plus 1 divided by 1 plus j. So if you'll add it, what you will get? 1 minus j minus 1 minus j into 1, that will be multiplied. So 1 square minus j ka square. So you will get 1 plus 1 only. So 2. So minus 2j divided by 2. You will get minus j. Is this part is clear, guys? Prasanna, is this clear for you? Prasanna, Vaishnavi, is this things clear for you, or any doubt? Guys, just say, is this clear? Today also I am facing a network issue. Guys, we have a letter we should do also.